part 2. So now we're talking about interpreting this data output. We have to look at our assumptions of the ANOVA. The assumptions for the factorial ANOVA are the same. The last exception, though, is that the factorial ANOVA assumes the equal representation of groups. And let me pull up that exact information. It's called orthogonality, and there must be an equal number of cases in the groups. Now, if you recall, if you watched the other video that I did, I explained that you can go to analyze and you can go to descriptives and frequencies. And let's say we wanted to check the frequencies of the sock color and the Netflix to make sure that we had those groupings correct. We can go ahead and check it out here. We have sock color and Netflix. There's equal groupings. We can further look at those statistics if we want to and break it down. The other thing is when we did the one-way ANOVA, we checked that there was an even distribution of the data, that there was no skewness or kurtosis. And how I did that was I went to the descriptives and I just looked at the dependent variable. And when I went to options, I just checked for kurtosis and skewness, and then that came out in my output here. See, there we go. So there, again, it fell between -1 and +1 in both skewness and kurtosis, or ketosis, and all of a sudden we're discussing diabetes. Kurtosis, you're fine. It's not present. And if you were, you would have to adjust your values. So again, of course, I closed my other box. So univariate, general linear model, I have these here. One piece of information is the post hoc. If you read the Lab 5 comments that are in the midterm zip file, it does ask you for post hoc. It does not mean this post hoc. It means our observed value. And if you want to see more about that, go ahead and pull up the discussion board posts. Okay, so you make sure you do your operational definitions. You've explained your sample size, you have your study design, you've met your requirements for the ANOVA, and now you should have 2 null hypotheses and 1 interaction effect hypothesis. So, and they are written in future tense, so there will be no significant difference in the gross income of people who have black or red socks and those who have or do not have Netflix at home. So the first one would be, there would be no significant difference in the gross income of people who have red or black socks. The second null hypothesis, H sub 0, 2, or H sub 0, not sub 0, Ho 1, Ho 2, there will be no significant difference in the income of people who have Netflix and do not have Netflix at home. Now, the interaction hypothesis, null, would be there would be no impact or significant difference of interactions between people who had red or black socks and those who have or do not have Netflix at home. Sorry, I was distracted because I was reading ahead. Okay, so when we go down and we want to interpret first, we want to go to our Levine and we want to look at it from a perspective of, did we meet our homogeneity of variance? If we look at our significance values, which are here, our p-values for the Levine, They are greater than our alpha of 0.05, therefore we can reject the null in regards to homogeneity of variance, and not in the outcome of our study, but in regards to that. And we can validate that we have met that need, or of the assumption of the ANOVA, the factorial ANOVA. So we've met with no kurtosis and skewness. We've met it that we have equal grouping. We have met it that we have homogeneity of variance. So we have we have met our and our sampling. And I'm assuming that your sampling justification for how you chose your sampling was not just random sampling, and you articulated that as such. All right, so I'll stop this recording here, and when we move forward, we'll be interpreting the main and interaction effects.